In this application problem, we're given a problem in words, and our first task is to translate this statement into a algebraic equation. So we have two variables here, m and t. M is representing distance in miles, and t is representing time in seconds. So in the problem, it states that the number of miles can be estimated by counting the number of seconds between the bolt of lightning and the associated clap of thunder, and then dividing by 5. Rather than jumping straight into the equation, what I like to do is simplify the problem in words. What I mean by this is we could restate this problem more simply as number of miles is number of seconds divided by 5. So miles is seconds divided by 5. When you simplify the wording, now it's much more apparent how to translate this into an equation. So number of miles, we have a symbol for that, m. The word is always will translate to an equal sign. Number of seconds, we have a symbol for that, that's t. So seconds divided by 5, we could say t over 5. So that's the formula for part A. M is equal to t over 5. The number of miles is equal to the time in seconds divided by 5. So now we have a relationship between m and t. This relationship could be expressed in a number of different ways. In part B, our goal is to solve this formula, solve this equation for t. What that means, solve for, means isolate the t, get the t by itself. In this case, we have t divided by 5. How do you get rid of a divide by 5? You apply the opposite, which is multiply by 5. So we can multiply both sides of this equation by 5. If we distribute the 5 on the right, the 5 and the over 5 cancel. We have t, and on the left, 5 times m, 5m. So these two formulas are equivalent. In the first case, it's in terms of m. The second case, it's in terms of t. In part 3, if lightning strikes 2.5 miles away, how many seconds will elapse before the thunder is heard? So the question is, how many seconds? So time is the unknown. So we're solving for t. We're given a value for m. Remember, m is distance in miles, so we're given the distance is 2.5. So we're going to plug in 2.5 for the variable m, and we're going to solve for t. Now it makes more sense to use the form from part B because we're looking for t, and in part B we have t by itself. So t is equal to 5 times m. In this case, m is 2.5, so t is equal to 5 times 2.5, and if we multiply this out, t is equal to 12.5 miles. Make sure to always include the units in the answer.